Waterfall model.
The waterfall model is a sequential design process, often used in software development processes, in which progress is seen as flowing steadily downward through the phases of conception, initiation, analysis, design, construction, testing, production implementation, and maintenance. The waterfall development model originates in the manufacturing and construction industries. Highly structured physical environments in which after-the-fact changes are prohibitively costly, if not impossible. Since no formal software development methodologies existed at the time, this hardware-oriented model was simply adapted for software development. The first known presentation describing use of similar phases in software engineering was held by Herbert D. Bennington at Symposium on Advanced Programming Methods for Digital Computers on June 29, 1956. This presentation was about the development of software for Sage. In 1983 the paper was republished with a foreword by Bennington pointing out that the process was not in fact performed in a strict top-down fashion, but depended on a prototype. The first formal description of the waterfall model is often cited as a 1970 article by Winston W. Royce, although Royce did not use the term waterfall in this article. Royce presented this model as an example of a flawed, non-working model. This, in fact, is how the term is generally used in writing about software development, to describe a critical view of a commonly used software development practice. The earliest use of the term waterfall may have been a 1976 paper by Bell and Thayer.
Model.
In Royce's original waterfall model, the following phases are followed in order. Requirement specification resulting in the product requirements document, design resulting in the software architecture, construction, implementation or coding, resulting in the actual software, integration, testing and debugging, installation, maintenance. Thus the waterfall model maintains that one should move to a phase only when its preceding phase is reviewed and verified. Various modified waterfall models, including Royce's final model, however, can include slight or major variations on this process.
Supporting arguments.
Time spent early in the software production cycle can lead to greater economy at later stages. McConnell shows that a bug found in the early stages, such as requirements specification or design, is cheaper in money, effort, and time to fix than the same bug found later on in the process. To take an extreme example, if a program design turns out to be impossible to implement, it is easier to fix the design at the design stage than to realize months later, when program components are being integrated, that all the work done so far has to be scrapped because of a broken design. This is the central idea behind big design upfront and the waterfall model. Time spent early on making sure requirements and design are correct saves much time and effort later. Thus, the thinking of those who follow the waterfall process goes, make sure each phase is 100% complete and absolutely correct before proceeding to the next phase. Program requirements should be set in stone before design begins, otherwise work put into a design based on incorrect requirements is wasted. The program's design should be perfect before people begin to implement the design, otherwise they implement the wrong design and their work is wasted, etc. A further argument for the waterfall model is that it places emphasis on documentation, such as requirements documents and design documents, as well as source code. In less thoroughly designed and documented methodologies, knowledge is lost if team members leave before the project is completed, and it may be difficult for a project to recover from the loss. If a fully working design document is present, as is the intent of big design upfront and the waterfall model, new team members or even entirely new teams should be able to familiarize themselves by reading the documents. Some waterfall proponents prefer the waterfall model for its simple approach and argue that it is more disciplined. The waterfall model provides a structured approach. The model itself progresses linearly through discrete, easily understandable and explainable phases and thus is easy to understand. It also provides easily identifiable milestones in the development process. It is perhaps for this reason that the waterfall model is used as a beginning example of a development model in many software engineering texts and courses. It is argued that the waterfall model and big design upfront in general can be suited to software projects that are stable, especially those projects with unchanging requirements, such as with shrink-wrap software, and where it is possible and likely that designers will be able to fully predict problem areas of the system and produce a correct design before implementation is started. The waterfall model also requires that implementers follow the well-made, complete design accurately, ensuring that the integration of the system proceeds smoothly.
Criticism.
Advocates of agile software development argue the waterfall model is a bad idea in practice, believing it impossible for any non-trivial project to finish a phase of a software product's lifecycle perfectly before moving to the next phases and learning from them. For example, clients may not know exactly what requirements they need before reviewing a working prototype and commenting on it. They may change their requirements constantly. Designers and programmers may have little control over this. If clients change their requirements after the design is finalized, the design must be modified to accommodate the new requirements. This effectively means invalidating a good deal of working hours, which means increased cost, especially if a large amount of the project's resources has already been invested in big design upfront. Designers may not be aware of future implementation difficulties when writing a design for an unimplemented software product. That is, it may become clear in the implementation phase that a particular area of program functionality is extraordinarily difficult to implement. In this case, it is better to revise the design than persist in a design based on faulty predictions, and that does not account for the newly discovered problems. In Code Complete, a book that criticizes widespread use of the waterfall model, Steve McConnell refers to design as a wicked problem, a problem whose requirements and limitations cannot be entirely known before completion. The implication of this is that it is impossible to perfect one phase of software development, thus it is impossible if using the waterfall model to move on to the next phase. David Parnas, in A Rational Design Process, How and Why to Fake It, writes, expanding the concept above, the project stakeholders, non-IT personnel, may not be fully aware of the capabilities of the technology being implemented. This can lead to what they think is possible defining expectations and requirements. This can lead to a design that does not use the full potential of what the new technology can deliver, or simply replicates the existing application or process with a new technology. This can cause substantial changes to the implementation requirements once the stakeholders become more aware of the functionality available from the new technology. An example is where an organization migrates from a paper-based process to an electronic process. While key deliverables of the paper process must be maintained, benefits of real-time data input validation, traceability, and automated decision point routing may not be anticipated at the early planning stages of the project. The idea behind the waterfall model may be measured twice. Cut once, and those opposed to the waterfall model argue that this idea tends to fall apart when the problem constantly changes due to requirement modifications and new realizations about the problem itself. A potential solution is for an experienced developer to spend time upfront on refactoring to consolidate the software, and to prepare it for a possible update, no matter if such is planned already. Another approach is to use a design targeting modularity with interfaces to increase the flexibility of the software with respect to the design. Due to the types of criticisms discussed above, some organizations, such as the U.S. Department of Defense, now have a preference against waterfall-type methodologies, starting with MILS TD 498 clearly encouraging evolutionary acquisition and IID.
Modified models.
In response to the perceived problems with the pure waterfall model, many modified waterfall models have been introduced. These models may address some or all of the criticisms of the pure waterfall model. Many different models are covered by Steve McConnell in the lifecycle planning chapter of his book Rapid Development, Taming Wild Software Schedules. While all software development models bear some similarity to the waterfall model, as all software development models incorporate at least some phases similar to those used in the waterfall model, this section deals with those closest to the waterfall model. For models that apply further differences to the waterfall model, or for radically different models seek general information on the software development process.